We're going to do number 45 from the Chapter 4 homework set. So here it is. Manny hits a home run so that the baseball just clears the top row of bleachers 21 meters high, located 130 meters from home plate. The ball is hit at an angle of 35 degrees to the horizontal and air resistance is negligible. Find the initial speed of the ball, the time interval required for the ball to reach the bleachers, and the velocity components and speed of the ball when it passes over the top row. Assume the ball is hit at a height of 1 meter above the ground. So the first thing we're going to do is draw a picture. So here's the picture I drew. It's pretty simple. It shows that the right is going to be our positive direction and up is going to be our positive direction as well. The distance it travels in the x direction is 130 meters. And because, as it said at the end of the problem, because we're assuming the ball is hit 1 meter above the ground, starts up there and travels up there, and that distance is really only 20 meters. And then also we want to remember that acceleration in the x direction is 0, and in the y direction it's going to be gravity, negative 9.8 meters per second squared. So it asked us to find initial velocity, time to the bleachers, and final velocity. I started with B to find the time because I thought that was the easiest way to start. So I used this kinematic and found V initial time by plugging in. So I used VO cosine 35 because cosine 35 would be the horizontal component of the velocity, and then I got that for VOT. And then I took that value and plugged it in for the y direction, so I used the same kinematic right here and then plugged it in. And for this one it would be sine 35 t, just because this is going to be the y direction. And then you still plug in what you got for VOT up here, down here. And you multiply, plug in t squared, because we're looking for t. And then it becomes tangent 35 because sine 35 over cosine 35 is tangent 35. And then you just solve for t, and then you get time equals 3.81 seconds. So I stored all of my values in my calculator, so if you do it and you just use the numbers that you get on paper, your answers will be a little off from what's in the back of the book, but that's okay as long as you know it's because you didn't, it's because you rounded. Okay, so then I found the initial velocity by plugging back into this initial equation that we have up here. So I went and I used what we found for time, so V initial time equals 130 meters over cosine 35, divide that by the time, so from here to here divide by time, and then you get 41.683 meters per second, and the book rounds it. So that's that. And then to find the final velocity and the final components, we have to find the components first to get the final velocity. So the initial y direction would be the V initial times sine 35. And then because I plugged it all into my calculator, I just went to the next step and found the final velocity, and I plugged that in. So here I plugged in what we had for final velocity, which was 41.683, and I still had it in my calculator. And then acceleration times time, and I got negative 13.4 meters per second for the final velocity in the y direction. And then for the x direction, I use this kinematic, but it's basically just to show that because acceleration is 0 in the x direction, the initial x velocity and final x velocity is going to be the same, and it's going to be V initial times cosine 35, which is 34.145 meters per second. And then to find the overall speed of the ball, I found the hypotenuse of what would be that triangle. So I just squared both of them, added them, and then square rooted their sum. And I got 36.68 meters per second, and I'm pretty sure the book rounds it. But yep, that's number 45 on the Chapter 4 homework.